Okay, with our part 2 video, we left off right here. We solved that r was equal to 0, r is equal to 1. By the way, in light of what we just talked about earlier, these are an integer apart, unlike what we did the other day. So that's why I changed the notes, and I wanted to do this very different thing. As soon as you see that, you could understandably let out an uh-oh, because that means we are going to have to do a lot more work. What that means is, in this regard, we've got case 2, right? So we're going to, come out with this other answer in due time. Well, let's go back to our sigma, this sum right here, and I don't think it's too much of a stretch. I don't think it's too much of a stretch for us to solve all in one fell swoop. If we were to get c sub k plus 1 by itself, knowing that, what we've got right here, this thing, all of it, has to be 0, solving for the higher ordered subscript, in other words, subtracting a c sub k, dividing by whatever's multiplied to c sub k plus 1, you quickly will arrive at this. But there are two cases, aren't there? There's case number 1, where you'd say, well, we've got r equals 0. And then there's case number 2, where we'd have r is equal to 1. So at this point, we could say, well, let's go ahead and generate this. If r was equal to 0, I think that's the nice case. I think that's the case everybody wants to, pay attention to. Anytime your r completely disappears, oh my goodness, that's delightful. That's lovely. You come over here, you'd say, well, if r is equal to 1, well, it's not like it's horrible. This would become k plus 2, and this would be k plus 1. But guys, you're about to hopefully notice that this is going to have a surprise in it. It's going to have something that's, dare I say, going to maybe become a little uncomfortable as you work these out. At first glance, you're going to say, hey, I don't see a big deal here. Let's just see. What do you think maybe my first k could equal here? K could equal, we think k would equal 0. But then all of a sudden you'd say, no, I can't let k equal 0. Do you see that? Boy, that's annoying. The first time we've seen that happen, right? But you'd say, well, gosh, man, that's, okay, I can't work that out. No, let's maybe try k equals 1. All right, so it's okay. And then we'd say, well, I'd get c sub 2, right? Would be minus c sub 1 all over. Well, 1 plus 1 is 2, and 2 times 1, and you'd get that. And we're not going to go crazy here and work out a whole bunch of different cases. Maybe just a few. Like if I let k equal 2, then this would be minus c sub 2 all over. Well, 2 plus 1 is 3, and 3 times 2, I'd get a 6. But remember, c sub 2, I could work that out. And that would become a positive c sub 1 all over 12. Maybe let's do one more, because these problems can get very, very lengthy. As we have k equals 3, we'd have negative c sub 3 all over. Well, 3 plus 1 is 4, and 4 times 3, you can see, well, that's going to be a 12. And now I'm going to go back to my previous iteration and plug in that c sub 3 value that I just found. And 12 times 12 is going to get you 144. So, we're going to have this. And here we go. All right. So, as we're working this out, as we're working this thing out, we can go ahead and say, hey, y would equal, just beginning to think about this, x to the r, and then we could say, well, we'd have to have a c sub 0 plus c sub 1 x to the 1 plus c sub 2 x squared plus c sub 3 x cubed, and so on, right? And I think this is helpful as you begin to take a glance at this. And very quickly we could say, well, we've got r is equal to 0. So we'd have x to the 0. I don't know what c sub 0 is. I don't know what c sub 0 is, but I can tell you I can get started here. And then I could say, well, here I've got c sub 1 x. C sub 2 was negative c sub 1 all over 2. And c sub 3, well, that's going to be c sub 1 over 12. I guess I went one step further. I actually found c sub 4. So we could say c sub 4 would be negative c sub 1 all over 144. And here's your x to the 4. Okay? So, of course, x to the 0, hey, that's just a 1. You could say, hey, look at that. What will trouble some kids, and it can trouble them a great, great deal, is they could say, well, you know, I just don't know what c sub 0 is. It's so weird. Everything else is based upon c sub 1. But guys, if you're really, really, really thinking, you could figure out what c sub 0 is even right now. Here's what I'm getting at. We could go back up to the top, the very beginning of this problem. And guys, if you're really thinking about it, you had a c sub 0 plus c sub 1x and so forth. And would you agree that when you'd be multiplying by the second derivative here, if you took the second derivative of this thing, that you'd no longer have a c sub 0 in the mix? Right? It would be gone after you took the first derivative. And I guess what I'm really getting at is this. If you go back to saying, hey, if that works when I plug it in, you could see that that c sub 0 is going to have to equal 0 because I want the right side to equal 0. You'd say, I'm left with some constant right there. So you're really going to be able to even know from the context of the problem here that c sub 0 equals 0 to solve the differential equation. So that could be good. That could help you out. Well, let's keep coming over this way. And we could say, well, you just found one series solution. And now you're going to come over here and you've got case 2. And you think, well, my gosh, r is equal to 1. We worked that thing out. What could I let k equal here, do you think? Here I can let k equal 0, couldn't I? You know, the real problem was that denominator that I highlighted off to the left. So I'd have c sub 1 equals, well, now I'd get negative c sub 0, and here's a 2 and a 1. That would just be a 2. And, hey, things are looking pretty nice. And now I could let k equal 1, and I get c sub 2, and that would be negative c sub 1 over, well, 1 plus 2 is 3, and 1 plus 1 is 2. 3 times 2 is a 6. And we'd go negative. Here's c sub 0 over 2, all over a 6. We get negative c sub 0 over 12. And I think you can see what's happening. You can pretty much quickly generate some more. We get negative c sub 2. And yes. Oh, it was a negative inside. Thank you so much. Thank you for catching that. That's going to be a positive c sub 0 over 12, isn't it? There we go. So then what? Well, what you got, plain and simple, you've got your negative c sub 2 here. When you let k equal 2, 2 plus 2 down here is a 4. 2 plus 1 is 3. 3 times 4, you're going to get a 12. And you just found that c sub 2 is a positive c sub 0 over 12. And then we can divide by 12. And what are we left with? A negative c sub 0 all over 144. How about I stop here? You can think, well, why are you stopping there? You went a little bit further before. Yeah, but tell you what, I hope you're going to see what we're talking about. Right now, I had my y sub 1. That was my first series solution. And then all of a sudden, we're going to come to our y sub 2. It's x to the r. And we're going to have c sub 0. Now, by the way, it's okay to just use c sub 0. Yesterday, I changed them around and so forth, making some different things. We could change the constant at the very end. Maybe that would even make life a little bit easier to organize all this. And we're going to keep going. And then you could say, well, y sub 2 would be x to the 1. Remember, r is equal to 1. Then you'd say, well, I'm going to have c sub 0. I don't know what that is, but c sub 1 was this thing. I'll go negative c sub 0 all over a2, and that's an x. And then I'll say plus c sub 2. Well, that was my c sub 0 all over 12. And then you'd say, what about your c sub 3? Well, that's your negative c sub 0 over 144. And it's so easy to just kind of glance at this and, give a ho-hum, oh yeah, here we are, until you distribute that x back in. And you see, when you distribute that x in, you're going to say, well, I'll have a c sub 0x plus, here's a negative c sub 0 2x squared plus c sub 0 over 12x cubed minus a c sub 0 over 144 x to the 4th. And, again, we can kind of glance at that and just give a ho-hum, yeah, here you are. But remember, these are arbitrary constants. These are arbitrary constants, right? They could be all different types of numbers. Now, guys, if that's the case, you'd say, well, let's just call C1 was 1. Well, if that were the case, you'd have this, wouldn't you? Kids would look at that and they'll say, okay, well, yeah, I guess if C sub 1 happened to be the number 1, and it could, let's let C sub 0 equal 1. What do you get? The exact same solution. You're getting the same solution. So all of a sudden, you look at that and you think, oh my word, what on earth is going on? I'm getting the same solution. What in the world do we do? This is why we've got that brand new case. So guys, we're going to go ahead and just have some review right now. Please understand that the original problem that we had was x, y double prime plus y was equal to 0. And like I said, we could have made that into this if we divide by our x. Here's some review, and this is where it's going to get messy. You can say, given y double prime plus p of x, y prime plus q of x, y equals 0. You might remember this ugly fact, especially if you need to find a second solution. I'm hearing kids say, oh no, yeah, we're going to work this out. And this is why we need technology to help us. We're going to get a second solution. I hope you can see this is y double prime plus 0 y prime plus 1 over the x y. That means p equals 0. And that's going to help out tremendously. But we're going to have to work this thing out. And we're going to need Wolfram alpha to help us do that.